Alright guys, resistive circuit number 11. Ooh, it looks like things got real here. Look, we got a series parallel combination here. And we've got crazy stuff going on. We got a series circuit here that branches off right here. Come on, draw it. At a parallel junction. We can see that current is going to go in two different directions here. It goes through R6 over here, comes down through R2, gets to another parallel junction, and then current rocks through R5, and then goes to R3 and R4 before all of these circuits combine back to this point to go back to the source. Okay, so what do we got to do? We got to just break it down nice and slow. And what's this note at the top? Find RT without a calculator, and then calculate the total current. Good Lord. Alright, so we got to do this without a calculator now. Okay, well there's obviously a pattern, and that's what I'm trying to teach you, is that there should be a pattern with within each of the circuits, and then as you're doing, different ladder diagrams and everything like that, there's usually a pattern to simplify things. So let's see. I would start down here with R3 and R4, right? Because those guys are in series, and we're going to move our way back up to these parallel nodes right here. So let's see. R3 and R4 are in series, so we're just going to add those guys up, 4.7 and 4.7, and I'm just going to write in here with the little arrow my total here. So that's 9.4 kiloohms down that row. Now, current also goes over here and goes down this parallel path over here. Ooh, look at that, 9.4 kiloohms. Okay, so those guys are the same. So what do we know about a parallel circuit that has two equal resistance values? Well, we take the resistance and we divide by the number of paths. Right? So in this case, we have two paths, both of them at 9.4. So if we take 9.4 divided by 2, that gives us 4.7. So everything down here is the same as a 4.7 kiloohm resistor. So we're going to write that in, 4.7 kiloohms from there down. Beauty. Okay, well, that 4.7 is in series with this R2 at 2.2. So we're going to do the 4.7 plus the 2.2. Right, so from there down, we've got 6.9 kiloohms. Right on. Current is going to go in this direction though as well, though. It's going to come down here, and look at that, 6.9 kiloohms. There is a pattern to this circuit, and we can do this without a calculator. Okay, so again, we have two paths. All of this noise down here is 6.9. This guy is 6.9, so again we have two parallel paths with the exact same resistance, 6.9 and 6.9, and to find the total resistance for those guys, we're going to take the 6.9 and divide by the two paths, and so from here down we've got 3.45 kiloohms for our value. Okay, last thing we need to do is go through the last resistor, R1. So our total resistance is going to be 4.45 kiloohms. Right on. So massive Ohm's law. Here we got 240 volts. We just found that we have 4,045 ohms. I'm going to keep it as 4.45 ohms just to reinforce the fact that if you take your 240 and you divide it by 4.45, so let's do that. Let's see, 240 divided by 4.45 gives me 53.93. Now, that's not in amps, remember, because we just divided by thousands of ohms. I can't draw it today with this pen. Okay, so that guy is going to be in milliamps, 53.93. If we took the same values, if we took the 240 volts and divided by 4,450 ohms, right? So 240 divided by 4,450 ohms, that gives me a current of 0.0 And that's in amps, right? So you can see that this value and this value are the same. You don't have to do the conversion to 4,445 ohms. If you keep track of the fact that you're dividing by 1,000 ohms, you're going to get 1/1000th of current. Excellent. Okay, so that seemed crazy. Look at that. So series parallel combination where we had 1, 2, 3 different parallel paths, right? But we were able to break it down and we were able to actually find our total resistance without a calculator.